This is the last talk of the dev room from Postgres this year at FOSDEM. And this talk will be done by Patrick Foncel. So please give him a warm hand. Good luck.
Hello. Oh. Hello, everyone. I hope you're not waiting for the next talk, because maybe you will be a little disappointed. Who was already there for Magnus' talk about replication? Oh, there will be some kind of redundancy, but that's not the same topic. So let's start. I'm Patrick Foncel, and I work from Data company, a French I'm PostgreSQL consultant and trainer since 2013. I have my first contact with PostgreSQL in 1999, but discovered the community quite late, so I'm not very known. And I never stopped using PostgreSQL since I first started, so when I was a student. This is my first talk in English, so I will be more comfortable if you do not ask questions, please. But feel free to come and discuss with me after, or if you miss me, I've got a Twitter account, and you can contact me this way. And well, don't be, you're not, maybe you will not want to follow me, because lots of friend things. Data is a company built on three essential pillars: the PostgreSQL database, of course, the development method, and of course automation, and cloud technologies. I mean, in these years, that's necessary. Let's go back to our subject. The subject is the many possible lives of a world file. And for the rest of the conference, I will become somewhere else. I will become something else. Hi. Soon, I will be a world file. What am I? What is my purpose? My purpose, in many databases call me transaction log. That's not wrong, because transactions are recorded inside me. In other databases, call me redo log. That's not false, because transaction recorded can help make redo. In PostgreSQL world, my name is write ahead log. So what am I? What is my purpose? My purpose is to record data changes as soon as possible. One of my purpose is to bring data consistency. The changes that were recorded are in binary special diff format that is not humanly readable. One of my purposes is to help restore data. So if you have a problem you have to make a recovery, I can help. And one of my possible purpose is to be the pillar of replication. Let's start with some theory, maybe the boring part. We live in PostgreSQL world, and PostgreSQL is an ACID database. ACID means atomicity, consistency, isolation, and durability. Atomicity means all or nothing, meaning that when you run a transaction, you don't want it to be inconsistent at some point. So, for example, in a bank, if you want to send money, you don't want the bank to get your money and then the transaction stops and you have lose money. That's not acceptable. That's why we have atomicity. Consistency means going from one valid state to another valid state. Maybe some constraint can be invalid at some point during the transaction, but at the end of the transaction, everything is valid. Isolation means many clients can run queries at the same time, as if they were alone in the database, almost. And durability, the part that is the most important for me, is that once the data are in the cluster, they will stay in the cluster. Just a little more about theory. Here we have a PostgreSQL server with memory represented and processes. And in the back we have data files and the wall space where all the walls are recorded. When a user wants to change data, he will issue a request to the database. If it's not already the case, the database will load the data from the data files into the memory. And then it will make the data change. At that point, the memory is called dirty because it's not the same as what it is in the files. This change is written into the wall file, so maybe inside me. At that point, if something bad happens, the PostgreSQL server is able to redo the transaction, to rerun it, because all the data are into the wall. So we can say to the user, okay, the transaction is committed. And later, the data will be recorded into the data files. That happens when you make a checkpoint, or when a checkpoint is made automatically. So let's go back to my favorite subject, me. My vision of time, I have a special vision of time. Human time is made of hours, minutes, seconds, days. Well, that's interesting for humans. My time depends on activity. So it is made of transactions. And when I say soon I will become a wall file, it can mean microseconds to years. To be more honest, it will be more realistic. It will mean maybe seconds to hours or days. I've got some expectation for my future life. I want to be a fair good worker, so I want to reach the end of file. For a human, that will mean something like reaching 100 years old, something like that. Other expectation, I want to travel. I want to see other things. I want to see the world. Well, other things. I don't want to be involved in any disaster, meaning recovery or promote things. That's where things happen in this case. I don't want to be part of it. But hey, we'll see. And I don't want to end up in cryo chamber. I think you call that cold storage, or maybe tape band, or DVD, or Blu-ray, something that look like that. But hey, I will have no choice in this. But you will see that all my goals may be achievable. There are some clues in what I will tell you. So let's talk about my life. And let's start from the beginning, the birth. My birth happened in many ways. I can be pre-allocated, that's a normal way, if there's not enough WAV files into the directory, some more will be pre-allocated at some point. I can be recycled from an ancestor's envelope. For humans, that would be very weird, but that's life for wolves. That's a normal process. Or I can be allocated on demand if you have a high activity on your cluster. Maybe you won't have time to pre-allocate every wall. Just after my birth, I will start to work. I will start my job. What is my job? My job is to record events. So the PostgreSQL processes will write events inside me. What kind of events? Data changes. Well, that's what I explained in the theory part. Maybe replication events. If you have replication, there may be some things to record. And special events, the checkpoints. When the checkpoint happens and the data are written into the data files, the checkpoint is written into the WAV file, the checkpoint event. Writing inside me happen in append-only mode, except for metadata, of course. What about the work time, the work period? When will I start working? I will start working after the switch from the previous WAV file. And I will work until the switch to the next WAV file. We'll see later what is the switch. My work will then be a continuation of others' work. So it's a teamwork. What about that switch? There is a normal switch that happens at the end of file. When I reach the end of file, a switch to the next role will happen. It can be a manual switch with the user function PG role switch in PostgreSQL 10, of course. And special cases can happen with PITR or promote, and I will talk a little bit more later. What about cryonics? I said I don't want to end up, if possible, in cryo chamber. What happens? At the end of the working period, when everything is okay, when the switch happens, I may be copied to another location. That's not mandatory, that depends on configuration. And this process is called archiving. How do you make archiving? You have to modify configuration, and put something, an external command, in the archive command configuration parameter. Then you will have to enable it with configuration parameter archive mode set to on. But be careful, when you archive, you may retain roles longer than you expected. For example, if there is a lag or an error in the archive process. Where are these archives? It can be many possible destinations. Can be a local or remote file system, that's pretty current. Can be tape-bound or permanent storage, which you would call cold storage, and I call cryo chamber. And maybe you would likely never been, you would likely never to use me again, because it will mean some problems, for example, a disaster, a cluster problem, and a recovery to do. An exception to this is non-streaming replication. What about my death? That's part of life. The death happened with the checkpointers process. In that case, I may be deleted or recycled. So the checkpointer process is like an angel of death. And it may be at the same time an angel of birth for another world after me. In some case, my death can be delayed. And I hope all of you would like to be the same. One thing, I can die with a manual action, which most of the time will mean an error, or maybe a disaster recovery plan if you are lucky enough to have an experienced DBA. And an interesting thing is I can be dead in one cluster and alive, or what you would call alive, maybe, in another cluster if you have replication. And about cryonics, would it mean dead or alive? Well, I cannot say everything so that humans can understand. I have my own life with special rules. When you recreate chamber, maybe at some time you will need to be defrost. Oh, sorry, I would need to be defrost. That happens only when recovering. At that time, I may be copied from archives, so it will be an inverted archiving process. And I would be fully read again to redo all the transactions inside me, even if there are other ways. Oh, sorry, didn't read. So now let's talk about my identity. I talked a little about my life. Maybe you want to know a little more about me. Let's talk about my name. My name is made of 3 parts, 8 digits each. The first part is the timeline ID. In my case, it is 2, padded with zeros. The second part is the logical file ID. In my part, it's 8, padded with zeros. And the third part is is the physical file ID. In my case, BB, padded with zeros. The timeline ID starts at 1, the logical file ID starts at 0, and the physical file ID goes from 0 to FF. An exception to that is the first of all worlds, the great ancestor. There is an exception because it starts at 1. More about my name. You can call me with a nickname 8BB. And don't confuse with that guy. His name is not that. 8BB will mean the BBth segment in the 8th logical file. All the IDs of my names are in hexadecimal. That's why I have written 0xBB. All my bytes, all my parts have an address. That's very useful if you want to precisely know where you're reading or writing. And there is a special notation, the LSN, the log sequence number, that is very used, at least in replication. So this notation, 8BB 3CB0 D2, is my byte 1,426. I didn't say much about the first part, the timeline. Well, what about the timeline? Something horrible happened in the past. I mean, that's why the timeline ID is 2 and not 1. And that horrible thing was that a part of the whole family was abandoned. I don't want to know much about that, but there are some details in the files 2.history, of course painted with zeros. In Oracle world, the timeline is called the incarnation. Let's go back to me, the version. I am tied to PostgreSQL version. That means that my internals may differ from one major version to another. For example, in PostgreSQL 9.5, there was a big change in the format. What about my size? My default size is 16 million, you're humans. My default size is 16 megabytes. I'm divided into blocks, by default 8 kilobytes each. And I've got my full size when allocated. Let's talk about something, the role level. There are 3 different levels available. The parameter for this is role level inside the configuration. And it allows me different life opportunities. And as it can change over time, it might change over time, I can have different role level in different times, inside me, inside the same role, inside me. Let's see those 3 levels. First level is minimal. It permits you to make a recovery, but only from a crash. As crash are pretty rare in PostgreSQL, you may think of that as immediate shutdown or unexpected stop. Maybe someone unplugged from the electric network or something like that. In role level minimal, I will bring data to consistency to the cluster. And that's all. My life would be very short in that case. So I hope the cluster configuration is not set to minimal. Second level is replica, which is the default in PostgreSQL 10. It permits more than minimal to make archiving and to make physical replication. So traveling for me. It permits also read-only queries on the standby. And of course, as it permits more things, there will be more information stored. But the size will always be the same. The third level is logical. It permits logical decoding, that is, for example, using a tool called pgsquiz, or it permits logical replication, that Magnus talked a lot about this. And of course, even more information are stored. What do you want to know more about me? Where do I live? I live in pgrole directory in pgdata, or in any directory that is symlinked as pgrole in pgdata. So you know almost everything about me. That's enough to make a passport, so I can travel. Well, what about my date of birth, date of issue or expiration of this passport, or my photo? Well, that's not a human passport, so I don't need that. I have to tell you something more about disaster management. So when you have a disaster, when you have a big problem, maybe at some point you will need to restart from a backup. So you restore that backup, then you replay the work that has been made after that backup. Maybe at some point you will stop, and then you will go back in production. Let's talk about a special recovery, the automatic recovery. That's not exactly what I just said. The automatic recovery happens after a brutal stop and will run automatically. You will not need to restore a backup because the cluster was still consistent at the last checkpoint. PostgreSQL will then look up for the last checkpoint inside the walls, and he will search from the last one to the oldest to find the checkpoint, maybe inside me. When it finds it, it then will replay the transaction, redo the events to the end. And then you will get your PostgreSQL cluster running. What about a deliberate recovery? In a deliberate recovery, you humans, will start from a physical backup. Then you will have to write a file called recovery.conf. In that file, you will put the instruction for the recovery. And in particular, you will need to set a restore command to fetch the wall. That the inverted command from archive command. So if it's a copy command, you will have to set the copy command inverted. And then It's the same as automatic recovery. PostgreSQL will search from a checkpoint and redo the raw files. So, me at some point. At the end, the timeline will change. There is a special deliberate recovery, which is PITR. That is point-in-time recovery. That's a deliberate recovery, but you will specify the end of recovery. This end of recovery can be a timestamp, a transaction ID, an LSN, or a name point. And then you will do the recovery, and you will maybe set an end of recovery action. That's a new thing in PostgreSQL 10. The recovery parameter for that is recovery target action, which by default is to pause, so you can check that everything is okay, that your recovery is okay. What about the timeline change? How does it happen? The last row of the recovery is copied inside the role directory to another name. The name of this copy will differ only from the timeline ID, and the content will differ from the recovery point. And of course, the old rule after the recovery point in the old timeline will be abandoned. So my favorite part, traveling. Remember, I want to travel. I have to plan a trip for that. So I will go from an origin, a source. It will be called a primary cluster, or a provider cluster, or maybe a publisher cluster. I will have to set a destination, a standby cluster, or a subscriber. And of course, a transport method. Replication can happen via archives or via streaming replication. The concept of replication is pretty simple. It's to have a continuously up-to-date clone of data. So to have that, you copy the data, and then you replay the transaction, all the events, all the change events. And who's the best at recording transactions? That's me. Let's zoom on the physical replication. To make this, you will have to make a duplication of the wall file. So, at some point, I may be copied to another cluster. And this is done mostly with streaming replication. In streaming replication, cascading replication is allowed, so that a destination, a standby, can be at the same time provider from another standby. And the replication is that I will be sent gradually by pieces, octet by octet. Logical replication is not the same concept. In logical replication, I would be decoded on the publisher side, then the information will be transformed to extract the row changes and replicate them. And in that case, I will be sent to feed another row in another cluster. So I will not travel. But that's okay, because my life will be useful for another row. Let's talk about two processes. The role sender. The role sender is the process that gets the replication connections and runs replication protocol commands that are required, and then he will send the role content to the target node. On the other side, there is the role receiver. The role receiver fetches the data. It permits redo events, so mostly data changes, and maybe he will send feedback if you use hot standby feedback directive. There is a special receiver process, pgreceive role, which is a command you can run. It is quite special because it collects and stores the data, but will not permit redo. I mean, not immediately, because there is no PostgreSQL instance at that time. That's an own command. So pgreceive role will make a streamed archive. You will have an archive gradually up to date. And for the replication, there is the last concept, which are replication slots. A replication slot is a client dedicated resource. In this resource, PostgreSQL will store the replication state of the replication for this client. And it will forbid deletion of any role until it is fully replicated. So that's one case where there will be a delay in the dev process. So that's it. It's time to me to get to work. I've got just information. I'm about to begin my life. I'm about to start my work. So is my whole life, which you have seen can be quite complex, can have many possibles, and I hope I will enjoy my life, and I hope you will enjoy your life too. And thank you for your attention.
Anybody with some questions? So,
questions, there are some other people who can answer.
yeah. That's the last talk. So thank you for attending, and see you next year here at FOSDEM again at Postgres Dev Room.
By the way,
We also have a booth. That is, the booth is up in building K on level 2, so you have to go the steps up or have to use the other entry.
and we have FOSDEM PG Day next year again.
And we have FOSDEM PG Day next year again, so one day before FOSDEM there is a Friday with one-track Postgres talks. So enjoy your time at FOSDEM. Bye.